with the exception, okay, of the nth derivative, okay, and derivatives after the nth, yeah, okay. These are constant, yeah, okay. So all derivatives up to the nth derivative, okay, are 0, and every derivative from the nth derivative on are constant integers, okay, are constant integers, and that's important, okay. So what have we shown? Let me try to do this. So 1. So what have we shown? What have we shown up to this particular point? Although it's not been very rigorous, yeah. Okay? Well, what we've shown is this: is that the function, the kth derivative of the function as 0 is equal to 0 for k greater than or equal to 0, but less than n. In other words, all derivatives, yeah, up to the nth derivative, but not including the nth derivative, when evaluated as 0 or equal to 0. We've shown that. And what else have we shown? Well, we've shown as well that the nth derivative, okay, the nth derivative, evaluate at x as a constant, so evaluate as 0, okay, is equal to some constant, yeah, okay, where is equal to c, where c is a constant, and more importantly, okay, it is an integer. Okay, and actually a positive integer at that. Okay, and now how the hell did I even get to that particular place to say that it's a constant as an integer? If we actually go back here, okay, we look at the nth term. Okay, well we end up with a to the n. Okay, times 1. Which is a to the n is a constant. It's a constant. Now, when we're choosing pi, okay, when we're choosing pi to be a rational number, okay, we're going to choose a to have a specific value, okay, and we're going to choose it to be positive, in which case b has to be positive, yeah, so we're going to choose a to be a specific value. So this constant here, yeah, is an integer, and that's really important, yeah. What about derivatives after n, yeah, the nth derivative after the nth derivative, yeah, well, what we also have is this, is that we have these derivatives, okay, evaluated as 0, okay, are also equal to a constant, yeah, okay. It's another constant, okay. Constant. If you think about it, the nth derivative's constant is going to get differentiated, which is going to go to 0. But the term just before the nth derivative's constant, yeah, the term just before it, yeah, okay. Let me just actually go back here. Let me just actually try to find this here so that we actually see what's going on, okay. So if you think about it here, we're at the nth derivative now, okay, I'm saying that this is a constant, okay, but the term after it here, the term just after it here, when I differentiate this again, so I differentiate this, it's n factorial f of n plus 1 of x, when I differentiate again, this constant goes to 0, but the next term goes to a constant, and it's actually an integer. It's the same argument that we've actually had right there. Okay, so that's important to keep that in mind as well. Okay, so it's another constant, and this is for k greater than n. Okay. So really what we're saying here is that function f of x, okay, that when we differentiate it over and over and over again, okay, that when we differentiate it up to the nth derivative but excluding it, we get 0. And when we differentiate it from the nth derivative onwards, we always get a constant term, okay, because everything else is going to fall off to 0 within that particular expansion, okay. What else have we also shown? Okay, well we've shown, okay, we have also shown, we're nearly there, shown that f of x is equal to f of a over b minus x. Okay, we've actually shown that particular thing here to be true. Okay, and I know what we said earlier on is that when we assume pi to be rational, well then x becomes a over b. Yes, so this becomes f of 0. Yeah, which is going to either go to 0. Well, actually, because it's the function f, it actually is going to go to 0 when we actually evaluate it. As 0. Okay, so what's the next important result for us? This video is running 30 minutes here. Yeah, if you look at Niven's proof, it's very short. Okay, but I mean, I think it's important, and a few of our students have actually asked us to actually provide it in a lot of detail in relation to just the mechanics of the proof here. What's the second important thing that we need? Yeah, so our next important function. Okay. Okay. Now, up to this particular stage, the first important function that we had, the first important one was f of x is equal to x to the n times a minus b of x to the n over n factorial. So this next important function, yeah, it's an alternating function of derivatives. Okay, function of derivatives. Okay, that's important to keep in mind. Okay, actually, I'm going to just write it down here. So it's an alternating function of derivatives. Okay, so it's uppercase f of x, and what we're going to say is that it's equal to the original function f of x minus the second derivative of the original function. Okay, plus the fourth derivative of the original function. Okay, minus the sixth derivative of the original function, plus all the way through. Okay, the last term in it is going to be, well, if you think about the last term, yeah, okay, there's n terms, okay, and what I'm doing is this particular function here, we're actually just giving you the function and anyway, yeah, so it's going to continue in this particular fashion, and it's going to go all the way through to, well, you can see the coefficient is dependent on the power here, yeah, okay. So what we're going to have is, you know, when the derivative is 0 here, it's positive. When it's 2, it's negative. When it's 4, it's positive, and so on and so forth. Yeah. So it's going to be equal to minus 1 raised to the power of n times f of 2n of x. That's the nth term in this function, and that's the way we're actually going to define it. Yeah. Okay. What about the terms just in front of it? Okay. Well, the first term in front of it would be minus 1 to the n minus 2 times f of 2n minus 2 of x. Okay, that's the term just in front of this term. Don't forget, we're going up in tools. Yeah, we're starting off here is f of x, which is like the 0th derivative. Yeah, then the second, then the fourth, the sixth. So when I get up to the last one, it's the 2nth derivative. Yeah, so the one before it is going to be minus 2 derivatives before that one. The one before that is going to be, and so on and so forth. You can see actually what's happening here, hopefully. So this is just a function. It's a function of derivatives of f of x, yeah. Okay. But what we're going to do now is we're going to differentiate this function. Okay, we're going to differentiate it twice. Okay, that's really, really important. So we're going to differentiate this function twice. Okay, so we're going to calculate what f of double prime of x is. Okay, so we're going to differentiate it twice. So what happens here? Well, what happens here is that this gets differentiated